Hello everyone and welcome back to another CHE 101 video. So for today's video, we're diving into chemical engineering mathematics or CHEMAT 4, and we will start with the introduction to power series. So what is a power series? A power series is basically an infinite sum of terms that depend on x. So unlike regular series where we just add up numbers, here each term is a function of x and it is written in this form, where Cn are the coefficients, a is the constant, and x is the variable. So the big questions we always ask is, for what values of x does this sum actually make sense? And that's where convergence comes in. So a power series converges if adding up all its terms give a finite value. But whether or not that happens depends on x. The set of x values where the series converges is called the interval of convergence. So we'll be using tests like the ratio test to find out if the series converge or not. So the ratio test is a simple way to determine if a series converges or not. So here is the formula. If the limit is less than 1, the series converges. If the limit is greater than 1, the series diverges. And if it is equal to 1, the test is inconclusive. That means we'll be needing other tests. So by applying this test, we can determine the radius of convergence, and that would be the following topics. So for example, let us figure out if this converges or not by applying our formula. So our Cn is going to be the rest of the terms aside from the quantity that has x in it. So it would be 1 over n factorial. Okay, so if we plug it in here, it would be n plus 1 over n plus 1 factorial over xn over n factorial. So you might ask, where did this come from? As I've mentioned earlier, our C of n, or our Cn, is 1 over n factorial. So as you can see here, in this formula, we'll be adding 1 to the n, and it should be inside the factorial sign. Okay, it should not be outside. Then our Cn is this. Likewise, this is our x minus a raised to n plus 1. And this is our x minus a quantity raised to n. Is it coming all together now? Okay, good. Now let us evaluate this. If we substitute infinity inside all n, we will get x over infinity, which is equal to 0. So since 0 is less than 1, the series converges for all x. Which brings us to our next topic, all about the radius of convergence. So the radius of convergence, or denoted by the letter R, determines where a power series is valid. So if we have a power series centered at x minus a, the radius of convergence satisfies x minus a less than r. So inside this interval, the series converges. Outside this interval, the series diverges. So this concept is useful because it tells us how a power series, or where a power series can be used effectively. So we have 3 cases. First is the power series converges at a single point. Second case is it converges for all x as seen in the previous example. Third case is it converges within a certain interval. So here is a simple illustration for us to visualize the radius of convergence and the ratio test. So as you can see, inside this interval is where the series converges. If it is outside that interval, that means it diverges. So if the ratio test yields 1, it can be found here at the endpoints, and it may converge or diverge. So that's why we would be needing other tests to find out if it does converge. So in complex analysis, we also extend the idea of convergence to a complex plane in which we call the agrand plane. So instead of an interval, we get a circle of convergence. So the power series converges inside the circle centered at A with radius r. Inside this circle is where all points lead to convergence and those outside lead to divergence. So the radius of convergence, as you can see, is not only applicable to real numbers, but also helps us where the series is valid in the complex plane. Okay, so for an example, you were given this series, find R. So if this is the tree, we can say that those inside the circle converges and those outside the circle diverges. So that is basically the gist of the circle of convergence. Just to give you a quick summary of the key takeaways, a power series is an infinite polynomial representation of a function, and the radius of convergence determines how far the series remains valid. The interval of convergence must be carefully checked at the endpoints, and in the complex plane or the diagonal plane, the series converges within a circle of convergence. So power series play a crucial role in calculus and mathematical analysis, and of course for us aspiring chemical engineers. And it is a powerful tool for approximations and solving problems in engineering. So that's it for an introduction, and I hope you guys get the basic grasp of what the power series is all about. Thank you.